Hi guys, welcome to Tech Geek. So today we are back with the daily Leetcode challenge problem that's out of boundary. Okay, so talking about out of boundary paths, it's basically a DP question that's dynamic programming. So if you guys are new to this, then I would request you all to please go through some basics of this and then come up with a question because it's not easy to grab everything on the first move. Then coming about those who are already into it, please pay attention as this could be tricky if you are not getting it in, you can say, a first chance or anything. Okay. Now talking about this question is a medium one, so don't think that it has a lot to be done. Just a basic approach and it would work. And this question is basically asked in various product-based company. So pay attention while you think and have a clear mindset of problem solving while working on these problems. So let's see what the question says. The question says that you are given an m into n grid with a ball. Okay, now the ball position, that's the initial position, with a index of start row and start column is mentioned. You are allowed to move ball to one of the four adjacent cells in the grid. You have to make at most max move, so that means from 1 to max move you can make any number of moves, and in that way it should cross the boundary. Now it is said that you have the five integers, that's number of rows, number of columns, maximum, start row, start column, and you have to return the number of paths in such a way that it will cross the grid boundary. And answer could be large, so you have to return with mod of 10 power 9 plus 7. That's the first example they have given. Let's see. Okay, in the first example, they say it's a 2 by 2 matrix. So first let's see this 2 by 2 matrix. That would be quite easy, and then we'll talk about others. Okay. Okay. For the first option, it says we have a 2 by 2 matrix, and ball is placed at 0, comma 0. At most, you can make two moves. So if you talk about at most making two moves, so for the first position, for every position, we'll have four ways to go. If we talk about vertical upwards and horizontally left, this crosses the boundary, this crosses the boundary in one move. That means it's less than 2, less than or equal to 2. Yeah, you can take up. So we got two valid answers. Now talking about these. You came with first move here, first move here. Let's write it 1. Again, is it less than? Yeah. If it's less than 2, again we can try for out of boundary values. Let's take for all 4. Actually 4. Why? Because we have this 2 here, and then now from one to another cell we are making one more move. So this is 2. Is it less than? Yeah. But it's equal, so you cannot move any further, right? Because you are exhausted with your max moves. But if you talk about these moves, are they valid? Yes, they are taking up your value. So as you can see, 1, 2, 3, 4, 5, 6. 6 are the valid moves that happen. And that's what's given in your first answer. Now if you talk about the same thing, same start point or end point, and same valid points. Okay. Max moves, let's take it as 3, a little enhanced one. Now the grid is different. This is the location that you have, or let's say the location of this also. Let's make it here. Okay. Now for you, case 3 now. Okay, you have to check how you can go. Again, check for all 4 possibilities. Here it's not crossing. For all 4 possibilities, if it's not crossing the grid, mark that grid as the number of moves that take it there. Okay, so this is 1 1 1 1. Okay, write it with this so that it's clearly visible. Okay, now are the moves exhausted? No. I have they crossed? No. Again, for each one of them you need to check for 1 1 1, right? So for this, in one move you're crossing, right? For others, you can write it as 2. 2. We'll check one by one for each of them. Okay. 2, 2, and again coming here would also give you 2. So let's write it. We still have 3. So for this one, 2. Will you cross? Yes. Here coming will give you 3. No need. Here, cross. 3, no need. Checking about this one. This will give you 2, 2, and again 2. So 3 cross, 3 and cross. These 3 will come to the boundary values, it won't work. Again coming to 1. So by 1 also you can cross. You can go here and then cross. So this will give you another 1. Why we'll take 2? Because the path is different. Again coming here and then crossing. Again 1 more. Okay. Let's talk about this. Going up and then crossing. Again 1. Going here 2. Can cross? No. Coming now? No. So we got the maximum moves that could happen. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 solutions that you'll get. If you see coming to this, so in these DP problems, what you need to check is for this particular problem, if in the boundary value you get a value that's less than this threshold in any boundary value, that means that's your answer. Okay. So if that could be done, that means your answer is there. Let's look at the solution now. Yeah, as you know, we'll be iterating. We'll find the paths. We'll check for all possibilities by moving in all 4 directions, and if the condition as said is valid, return 1, otherwise return 0. This particular solution will give you the answer in n into number of rows, order of number of rows into columns into max moves. Okay. So that's what our answer says. I hope the solution is clear. If in case there was any query, anything that you need to know, anything in the solution or anything related to any interview experience, do let me know. Till then, keep following. Thank you.